folks, welcome to our last free response question on this sample midterm. And this one's asking you to graph this absolute value function. And so there's a couple ways you can go about doing this. If you're not sure what this would look like, if you're like, hey, I'm not clear on that, just keep in mind, your quick and dirty absolute value function is a V, right? It's centered at it's kind of vertex is at the origin. And I can see I'm moving 3 right. Like this has been transformed 3 units right because of that -3. And it's been transformed 1 unit down because of that -1. So if I think about what it should look like ish, and I'll get beyond ish, right? But I go 1, 2, 3, down 1. Maybe the vertex is here. And I gotta account for the fact that I have a little bit of a compression because I have this factor of 1/2 out there. So before I even get going, I can get an idea of what that graph would look like. But let's say you weren't sure, you can this is always going to work. You make a table of values and you pick the X values and then you see what the corresponding Y values are. So if I wanted to, right, I could do X and Y and pick a bunch of X's. Oh, it looked like my video might have gone blurry for just a sec. Maybe it was auto-focusing. Now, I typically like to pick these, right? Those tend to be my 5 favorite, -2, -1, 0, 1, 2 as my X values, but I'm gonna be a little bit more strategic because I've been shifted 3 units to the right. So I'm gonna move all of these 3 units over. So this will be a 5, this will be a 4, 3, 2, 1. So let me go ahead and do that. I'm gonna shift things over. All right, so let me do, oh gosh, and I'm not sure if this is gonna go blurry again, but let me do 1, 2, 3, 4, 5, right? And let's see what we're getting here. All right, so if I plug, I'm actually gonna start with the easiest, or not easy, but easiest. If I plug 3 in, 3 minus 3 is 0. Absolute value of 0 is 0. 1/2 times 0 is 0. -1 will get me here, okay? I'm going to try 1 now, okay? So 1 minus 3 is -2. The absolute value of -2 is 2. 1/2 times 2 is 1. 1 minus 1, 0. All right, and if you're not sure what I'm saying, let me write this out. It would have been 1/2 times the absolute value of 1 minus 3 minus 1, which would be 1/2 times the absolute value of -2 minus 1, which is 1/2 times 2 minus 1. And I'm running out of space, but I get 1 minus 1, which is 0, okay? All right, now because of symmetry, I think that's also gonna be the case with 5, but let's check it. So I would do 5 minus 3, which is 2. The absolute value of 2 is 2. 1/2 times 2 is 1, and 1 minus 1 is 0. All right, let's try it with 2, and in theory, the Y value I get with 2 should also be the same Y value I get with 4. The only thing I would add is I'm going to have a fraction here because I know I'm going to have a 1/2 in play. All right, so 2 minus 3 is -1. The absolute value of -1 is 1. 1/2 times 1 is 1/2. And then 1/2 minus 1 is -1/2. And if you're not sure, right, let me do this, right? I've got 1/2 times the absolute value of 2 minus 3 minus 1. So this is going to be the absolute value of -1 minus 1. Which is 1/2 times 1 minus 1, which is 1/2 minus 1, which is ultimately -1/2. And when I plug 4 in, I'm going to get the same situation. Now, if I wanted to check this table on my calculator and I wanted to get a decent-ish idea of the graph, I could actually plug this in. So let me go back to my home screen. I would hit y equals, okay? And then I'm going to actually type this in. So I'm going to do 1/2. Oops, that says 1/5. Let's do 1/2. Now to get the absolute value function to pop up, let me scooch this up a wee bit. I'm going to hit my math key. All right. And if I go to the right by 1 to the num menu, I see my absolute value. So I just go ahead and I hit enter and I say, let's do x minus 3. And then I have to subtract 1. So I can actually make my calculator graph. Oops, you can't see the -1 as well. I can make it graph this function if I want, but for right now, I just want to check my table. So I'm going to hit second and graph because that's going to call up my table function. And then if we look, now this is starting at -5. Let me scroll down a little bit. I started at 1. Let me move this to the top so you can see like 1, 0. Great. And you can see when I plug in 2, I should have gotten -1/2. I did. This is the decimal -0.5, but same thing, right? Then a -1, then a -1/2, then a 0. So my table is matching the technology, right? So my handwritten stuff matching the tech, that's a good sign. It's always nice to have a check on yourself. So then what I'm gonna do is I'm gonna go over here and label and scale my axes, right? I've said I'm a stickler for that. And especially because there's these half units in here, I'm gonna make each square worth half a unit. So this is gonna be 1, 2, 3, 4. This is gonna be 5. And I'm gonna do that the whole way around. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Give me a moment. 1, 2, 3, 4, 5, -5 down here. Okay, so the first ordered pair I have is 1, 0, right? Then I have 2, -1/2. Then I have 3, -1, and then 4, -1/2, and then 5, 0. And I can see my V showing up, which is a good thing, right? That was my gut feelings, right? Because I know the general shape of an absolute value function, I was expecting a V. So now what my gut feelings were saying, what I was expecting, all of that is lining up. So that is good stuff. My handwriting or my handwork matches that table on the technology. It matches what I thought from intuition. It's just that much more of an indicator that I got this graph correct. If you wanted to check this on your graphing calculator, hit zoom 6, right? After you have this in your y equals, let's hit zoom 6. And it looks like that graph, right? Now I really have technology matching my handwritten work. So I'm feeling pretty good about this answer, okay? All right, so let's scroll up or scroll down. I'm not sure. I guess I would say scroll down. All right. So describe how the equation in part A is transformed from y equaling the absolute value of x. So just so that we can see it on the same in the same view screen. This was my function in part A. So let's talk about this. All right, the -3. That's going to shift my vertex 3 units to the right. So when that constant is being tacked onto that x value, right? When it's in that grouping symbol, that's going to shift you left, right? So since I have that -3, it's kind of counterintuitive. It actually shifts you 3 units right, 3 units right. And we saw that with our vertex. Oops, I should say 3 units right. I meant to write the word R-I-G-H-T, right? And I wrote vertex instead. This 1, because it's outside of the grouping symbols, it's actually going to change your y values. And because it's negative, it's going to shift down. So this is going to be 1 unit down. All right, and then that 1/2, because it's less than 1, it's actually going to kind of flatten the V, right? So if the absolute value of x looked like this, if I was going to do half of the absolute value of x, it's going to be flatter, right? It's not going to be stretched vertically. It's not going to be like a skinnier V. It's going to be a flatter V, so we're going to actually vertically compress it. And just to give you a heads up, when you talk about reflections across the x and y, that's when there's a negative involved. So had there been a negative out here, I know there's not, but if there had been a negative out here, then we would have reflected across the x-axis. All right, and if there's a negative inside the grouping symbols, you're reflecting across the y. All right, good luck on that exam. Thanks so much. Bye.